In today's lesson, we are going to be looking at scatterplots and lines of best fit. So this is our second lesson in our mini data management unit. We're going to be looking at a specific type of graph, and we're going to be looking at modeling our data. So looking at scatterplots and lines of best fit. So hopefully you know what a scatterplot is. If not, basically it's looking at two variables. It's looking at basically points on a graph. And with this scatterplot, we can get what's called a correlation coefficient. And this is sometimes called an R value. So correlation coefficient, or an R value, is a measure of the strength and direction of a linear relationship. The strength of a linear relationship is one of three things. It is either strong, moderate, right. Strong, moderate, or weak. And in terms of the directions, it's one of two. It's either positive, which means it would look something like this, going upwards, or it is negative, which would be kind of going downwards. And these R values, they can range from anywhere from -1 to +1. Now, if we had an R value of -1, so the one far extreme, we would consider this a perfect negative correlation. So that means that the points would basically form almost a perfectly straight line that is decreasing as we move to the right. And if R was 1, it's almost the opposite. We have a perfect positive correlation. So this means the points in our graph would be going upwards to the right in a perfectly straight line. And if we have an R value of 0, it means there's no correlation, right? There's no relationship, there's no correlation between the two variables that we're looking at. Now, obviously, we can have different R values, so we are looking at basically kind of a range of R values. So from -1 to -0.6, we would have what we call a strong negative correlation. Right, so the -1 is obviously a perfect negative, but anything from -1 to -0.6 is a strong negative. So visually, that might look something with our points, maybe something like that, where we can clearly see that it's going downwards in a negative fashion. From -0.6 to -0.4, we have what is called a moderate negative. So that's something where we can see the decreasing pattern, but maybe the points don't quite form a straight line, right? But we still do clearly see this negative pattern or negative trend. Maybe something like that would be considered a moderate negative. From -0.4 to 0, we have what is called a weak negative. So that, again, that could be something where the points are a little bit more spread out. But again, we still see a slight downward trend. Right? Maybe the points aren't that close together. Right, they don't really form a straight line. It might almost look like there is no correlation, but the points, there is still that slight downward trend. From 0 to 0.4, so now we're in the positive values. So it's the exact same kind of idea, except now we're going in the positive direction. So that means our points are going upwards. So this might look something like this. From from 0.4 to 0.6, we have a moderate positive. So again, we can see an upward direction. The points are probably closer together. They're less spread out. And then from 0.6 to 1, we have a strong positive. With again, 1 being a perfect positive. So here again, we see the points basically forming a straight line, or very close to a straight line. Now we don't have 0 in there, but if it was 0, 0 would basically look like a bunch of, basically it looks like a blob, right? There is no kind of clear kind of pattern or anything like that. So if I just kind of go off to the side, so 0 might look like something like this, right? There doesn't look to be any sort of trend. Right, so the R value of 0 might look something like this. There is no kind of positive or negative, right? It just looks kind of like points all over the place. So that's what an R value of 0 might look like. So let's go into an example. Right, so the data below indicates the distances and times from E.L. Crosley to other DSBN secondary schools. Right, and if we're looking at this table of values here, we can see that we have 2 schools where we don't have any information, or we're missing some information for. Right, we're missing the time for the DSBN Academy, and we're missing the distance for Greater Fort Erie. Right, so we want to basically figure out what would these 2 values be. Right, now normally if we had a table of values, right, we would say, okay, find the linear relationship, find the multiplier, find the constant. However, looking at these values, we don't quite see a linear relationship, right? There's not a nice pattern between the distances and the times. We might be able to approximate it based on some of the other values, but we might not be accurate. So what we need to do is we need to use technology first to graph this information. So we're going to graph this information in what we call a scatter plot. So you can use like Google Sheets, you can use Excel, you could use a graphing calculator. There's many different options. We're going to use Google Sheets just because it's pretty straightforward. So I've already inputted that table into Google Sheets. So I have all my data here. And what we're going to do is we're going to highlight the 2 columns of the 2 variables, distance and time. I'm not going to worry about the school. And I'm going to go Insert, Chart. And now it's automatically creating a scatter chart. And here I can see all the individual points, right? All the individual schools. So here where there is a, if it works, it shows me. So I have a distance of 8.8 and a time of 13, right? So I see Centennial is this point, right? I see all my other points laid out here. So this is my scatter plot, right? I'm looking for a relationship basically now between the distance and the time. Distance being the independent, time being the dependent. Basically, the time is going to depend on the distance. So I've created my scatter plot. I want to now create a line of best fit. I want to create a line to represent this data, or to model this data. So if I go over to edit, I click the 3 little buttons, I click edit chart, I'm going to go to customize, and I'm going to click on series. I'm going to scroll down until I see something called a trend line. Now a trend line is another word for a line of best fit. I'm going to check off that box, and now we see our line. Right, let me make it a little bit thicker and a little bit more solid, and let's change the color. So I see my line of best fit. So this is a straight line, a linear line that will model my data. Right? So this is the line that we're going to use to model our data and make predictions. Now it is a straight line, a perfectly straight line. And the idea is for it to basically get as close to as many points as possible and match the trend, right? Or match the pattern or the direction that it's going. Now Google Sheets is going to automatically do that, but if you had to draw one for yourself, right, you'd want it to, again, match the pattern or the trend, so this kind of upwards trend of our data, and be as close to as many points as possible. It doesn't need to go through all the points, but it wants to you want to try to draw it so that it's as close to all the points as possible. But when you're doing this with technology, you don't have to worry. it will do the best one possible. So now I have my line of best fit. I want to determine the equation for this line. So we're going to keep on scrolling down to where it says label, and we're going to say use equation. And now we can see an equation pop up of 0.805 times x plus 5.25. So that is going to be my equation. So I'm just going to write that down and we'll come back to our screen in a second. So I'm going to write down the equation y equals 0.805 x plus 5.25. So that is our line, or the equation of a line. Now you see that little star, that just basically means multiplying. So 0.805x plus 5.25. So coming back to our note, right? So we have our equation of a line, right? We have our m value, right? M, or our multiplier, 0.805. So basically that means for every kilometer, right, our time increases by 0.8 minutes. And we have our b value, which is 5.25. So this says that if our distance is 0 kilometers, our time would still be 5.25 seconds. Now that doesn't quite make sense, right? If we're 0 kilometers away from the school, how does it take us 5 minutes to get there? Again, some of the values might not make sense, especially that b value, but based on the data that we have, right, we don't have a school that is closer or at 0 kilometers away, so we can't really include that data. Right? So if I go back and take a look at my graph, we notice that the line of best fit does not have to go through 0. It's okay to go through a value. Obviously, the scales are a little bit off. We don't see them fully, but this would go through if we were to extend it. See if I can extend it or make it minimum value 0. There we go. So now I can see it a little bit better. So I've just kind of customized my graph. We can see it doesn't go through 0, 0, which is fine because the line of best fit may not do that. So I have my graph now. I see it. I have my equation, which I was able to get from the technology. I can figure out my m value and my b value from that equation, or the multiplier and the constant. The next question, I'm going to come back, says describe the relationship between the distance and time from Crosley to the DSBN schools. And we want to describe it in terms of strong, moderate, or weak, and positive or negative. So let's go back to our graph. And if you recall from our lesson, we just said that the R value tells us the strength and the direction. So this program will give us an R value. We're going to go to series again. We're going to scroll down below the trend line, below the equation. It says show R squared value. So if we click on that, we get an R squared value of 0.849. So this is what we're going to use to help us find our R value. So I'm going to write this out. So we have R squared is equal to 0.849, just so I have that on record. So let's come back. My R value is actually going to be the square root of our R squared value, or 0.849. We get an R value of square root of 0.849. We get an R value of 0.921. So with that R value, that tells us two things. One, it tells us that it is a strong correlation. So because of this value here, it's between 0.6 and 1. So this is a strong correlation. But I need to determine whether it's positive or negative. So I'm going to erase that for a second. So it's strong. Now, looking at the graph, I'm going to jump back again. Sorry for the back and forth. Right. looking at the line, we can tell that this is going upwards to the right. So this is a positive relationship, right? So it's a strong positive relationship. Now, just be careful, because when you take the square root of a number, your calculator is always going to give you a positive value, right? But when you take the square root, you actually get a positive or a negative value, right? Because think of this, for example, if I had the square root of 3, my calculator, or sorry, not the square root of 3, the square root of 9, my calculator would give me 3. Now, that makes sense because 3 times 3 equals 9. However, I could also have negative 3 times negative 3, which also equals 9. So when we take the square root of a number, we're actually getting two values, plus and minus, or a positive and a negative. So realistically, this R value is positive and negative, right, or positive or negative 0.921. We're choosing the positive one because when we look at the graph, we can clearly see a positive relationship. We can clearly see the line is going upwards. It has a positive slope. It is a positive linear relationship. So again, based off of this R value that we got from the technology, it is a strong positive relationship. Now, lastly, we did have two missing pieces of information, right? We didn't have the time to get to DSBN Academy. We only had the distance. And for Fort Erie, we had the time, but not the distance. So what we're going to do now, and the whole reason we came up with this line of best fit, the whole reason we came up with this equation, is to be able to make predictions, or to be able to say, hey, if I know this time, or if I had this much time, how far could I travel? Or what's the, if I know it takes me this long to get to this school, what would be the distance? Or vice versa. So I'm going to write out my equation again, the 0.805x plus 5.25. So y equals 0.805 x plus 5.25. And I want to determine the time to get to the DSBN Academy. So in this case, I have to be given a distance. And I am, because if I go back to my table, I do have a distance here of 14.5. Right, so that means that from my table, my D value is 14.5, or in other words, our X value is 14.5. So in our equation, we can replace X with 14.5. So Y equals 0.805 times 14.5 plus 5.25, and I get a Y value of calculate that, I get 16.925. I'm just going to round it to this. So this means then, therefore, it takes 16.92 minutes to get to DSBN Academy. For E, right, similar idea. We're going to use the equation from the line of best fit. So the Y equals 0.805 x plus 5.25. I'm going to be substituting a value in. However, right, in this case, because I know the time, I'm going to be looking for the distance. Or in other words, I know the Y value, which is 38. I know it takes me 38. That's based off the table. Right, if I scroll back up, we see the time of 38, but we're missing the distance. So I'm going to plug in 38 for Y and solve for X. So this is a two-step equation. I'm going to move the 2.2, or the 5.25 over, or subtract 5.25 from both sides. One side is going to cancel out. I'm left with 32.75 equals 0.805x. I'm going to divide both sides by 0.805. One side cancels out, and I'm left with x is equal to 40.68. So 40.68, or roughly 40.7, or roughly 41. So therefore, the distance is 40.68 kilometers. Right, so based off of that model and the equation that I got that will help us make predictions, based off of the data we entered, we're estimating that the distance to Greater Fort Erie is 40.68 kilometers. So again, that's why we graph this data. That's why we come up with, or we use the technology to come with equations, is so that we can make predictions. We can model what we think is going to happen. We can figure out other values. If we know one variable, we can figure out the other, or make estimations or predictions. Right? Are these going to be accurate? No, but they should be close. And based off of that R value, right, that does help tell me that, okay, yes, there's a very strong positive relationship. So this equation is going to be very close to true. Obviously, the more data we collect as well, if we had more distances and more times, right, the equation might change. But again, based off of what we have, the equation will work to help us estimate. Right? Obviously, other factors come into play as well. So again, the main thing from this is understanding what the R value stands for. What does it represent? What does it tell us about the relationship? And then just how can we use the equation for the line of best fit to make predictions.